Hello, welcome to the fourth homework of the data science. And in this homework, we are going to do. Okay, where was it? It was inside of the section model 3, 3.4. Yeah, okay. Amazon SageMaker training a model, lab 3.4. And and in this lab, uh, you will continue exploring the biomechanical vertebral column dataset. You will first split the dataset into the three split datasets for training, validation, and testing. You will then use this data to train a machine learning MML model by using the XGBoost algorithm. And okay, we're starting the lab and going into AWS. Then we are opening Amazon SageMaker, Notebook instance, and Jupyter Lab. Then, okay, we're then closing this one. I'm starting the lab right now, and I will stop the recording now, and I will restart the recording after lab is started. Hello again, and 3.4 lab is already opened now. Let's go dive into it. Amazon SageMaker, and yeah. Notebooks, notebook instance, Jupyter Lab, was it? Yeah, 3.4. It's opened now. Here, okay, cheat sheet. Okay, I will not read it. Actually, it's just an cheat sheet, tuples, loops, and file handling functions, numpy, and the other stuff. Okay, go to machine learning. The lab overview is, in this lab, is a continuous of the model quest labs in module 3. In this lab, you will split the data into three separate datasets: training set, validation set, and dataset. In the training set, this will be used to train the model, and in the validation set, this will be used during training to validate the model, and in the test set, this will be held back and used to produce metrics after the model is trained. You will use the dataset in upcoming lab. With the split data, you will train a XGB boost model by using Amazon SageMaker. And introduction to business scenario. You will work for a healthcare provider and want to improve detection of abnormalities in orthopedic patients. You are tasked with solving the problem by using the machine learning. You have you have access to dataset that contains 6 biomechanical features and target of normal or abnormal. You can use this dataset to train a ML model to predict if a patient will have an abnormality. About the dataset, we have 100 normal patients and 60 disc hernia patients and sypnolatis 150 patients. And okay, I'm checking for is there any good information. Okay, uh, basically we have 100 normal and 210 abnormal. And each patient is represented dataset by 6 biomechanical attributes that are derived from the shape and orientation of the pelvis and lumbar spine. The or attributes are pelvic indications, pelvic tilt, lumbar longus angle, sacral slope, pelvic radius, grade of the spondylolisthesis. The following convention is used for the class labels as DH, disc hernia, Cipollendis SL normal with NO and abnormal with AB. And okay, first we are importing data in here and exploring the data. Okay, you will start with a quick reminder of the data in the dataset. To get the most out of this lab, carefully read the instruction and code before you run the cells. Take time to experiment. Okay, we are taking the show and row and columns in here and preparation data. For this lab, you must split the data into 3 datasets, and internet search will show many different ways to split datasets. Many code samples that you might find will split the dataset into the target and features. Then they will split each of the datasets into 3 subsets, which results on a total 6 datasets. It will be probably with the first, we're gonna dividing into the 3, isn't it? Okay, let me read again. Sorry. Okay, we are dividing into 2, then 3. Probably the 2 of them is for the normal and abnormal. Then the other 3 is for the differences between the samples. I mean the samples is probably dividing into for the this one's probably like dividing into 2 with here and here, then dividing to here, here, and the other ones. Okay, we run that one. Okay, we are running to here, moving the target column position. XG boost requires the training data to be in a single file. The file must have target value be the first column. Our first column is in here, I guess. Actually, wake off data. Okay, it will be probably like one. Okay, it's not given. Shouldn't let me open these ones. Okay, wake off. Okay, these are dividing to some tonsils in here. Okay, these are the attributes, and there's a class, and this is the data. Okay, yeah, let's come to here again. And our columns is the class is the degree hypnosis name, and class is pelvic indicator and pelvic tilt, lumbar angle, scalar slope, pelvis radius, and all of them is objects. Splitting the data, you will start by splitting dataset into 2 datasets, and you will use one dataset for training, and you will split the other dataset again for user validation and testing. Okay, you will use a train test split function from the scikit-learn library, which is a free machine learning library for Python. It has many algorithms and useful functions, such as the one you will use. Okay, these are the information use. And let me run all of them. Okay, in here importing the test splits and training validations. Okay, it's open now. Okay, these are the shapes of the train, test, and validate shapes. And test and validate is the same size, and train is the all of them, I guess. I'm not sure about it, but and the train class is 100. Okay, count all of them is integer 64. Okay, uploading the data to Amazon S3. GXBoost will load the data for training from Amazon Simple Storage Service. Thus, you must write the data to a comma-separate values, the CSV file, and then upload the file to Amazon. Start by setting up some variables to S3 bucket, then create a function to upload the CSV file to Amazon S3. You can reuse this function. For explore this function, note the following line. Data frame.to CSV and CSV buffer header false and index false. This line writes the pandas data frame which will pass it into the function into the IO buffer that names CSV buffer. You use a buffer because you don't need to write the file locally. To stop the column headers for being written out, use header false. To stop the pandas indexing from being output, use index false. To write the CSV buffer to Amazon S3 as an object, use a put operation on the object, which is property of the bucket, and it's given the example in here. Let me run in here to uploading S3. Then training model. Now the data in Amazon S3, you can train a model. The first step, you get a XGBoost container URL, and let me run these ones too. We are in training the data, which is the importing, and what can I say? Okay, the instance count defines how many instances will be used for this training, and a type is instance type for training. And make the other import SageMaker, and this is the execution role type. Okay, this is training time. Did I? Yeah. Let me run it too. Info SageMaker create and training job name. Okay, this is the information about the XGB model, and it is over. This process can take up. Okay, probably it's not run yet, and we have to wait for it a little bit. Okay, I will stop the recording for the. Oh, okay, it's now started at 20 in here, preparing the training. Okay, I will stop the recording till finishing this process. After that one, I will restart the recording and show the what's happened. Okay, I don't know why, but there is some taken the error in here, and creating the job time. Okay, and it's giving the error. I don't know why. I will just rerun it, all of them. Now let me rerun all of them. Yeah, okay. And I'm waiting a little bit for it. Starting the training job again, and I will play the other one in here. Let okay. Training second and 2 minutes. Oh, okay. It's a framework error in here. And the other one is in progress, and I will wait for the second training process till over. And I will stop the recording again, and I will wait for the finishing this process. Okay, now in my second training, it's completed, and let's go to here, and we can see host and the instance type is MLM for X large, and data source is from the S3 Amazon, and these are the inputs and training values in here, and binary is logistic, and it's all finished. And thanks for the listening. Have a good day.